to Menora Academy. This is a place where mathematics is made easier. Of course, we are here to serve you. Feel free to subscribe. It doesn't bite. Subscribe and always comment, share, and then like. Today, I will be taking you through Logarithm 2, very fast, Logarithm 2. And under it, we'll be looking at theories of logarithm. Okay, so follow me first. The logarithm of a number n to base x, written as log n to base x, is the power to which x must be raised to obtain n. Now, e.g., if log n to base s is equals to y. Now, this is the log form. X raised to power y, this x, which is the base here, go to take y as its own power, then n stands alone. This is what we call the index form. Index means power. Now, the definition of this logarithm is what we have here in summary. That a log of a number n, look at n here, that have the base of s, okay, is written as this, is the power to which x must be raised to obtain n. So the logarithm of a number, the definition of it is just the index form of it. So if they ask you to define a logarithm of a logarithm of a number is expressing that number in index form, which is the base goes to take y as the power, then the log, the number itself stands alone. The number itself equals to the base raised to the power of this value. Alright, so examples. Change the following to index form. They are in their log form already. Let's change them to this index form. To change them to this index form, what we are going to be doing is, first of all, solution to the first example. Now, under it we have a. This is our a, and then the a is given to the log of 100 to base 10, which is equals to what? Equals to 2. So if you want to take this to the index form, this is what you are expected to do. The base, which is the 10, goes to take 2 as its own power, while all of them equal to what? To 100. Now, this implies that what it means is that the index form is going to be 10 raised to the power of 2, which is equals to this 100. And it is true. Then, the B part, very fast, we have log of 8 in base 2, which is 3. This is log form. If you want to write it in index form, what you're going to have is this 2 will take this 3 as the power, then equals to what? 8. 10 raised to the power 2 is 100, 2 raised to the power 3, of course, is 8. Okay, so this is how to change from log form to index form, and also you can change from the index form to log form 2 in case you are asked to do so. Alright, now the example 2, very fast. Example 2 says, write down the value of the following. We are going to write down the value of the following log. First of all, let's write down solution to example 2. The A part says we are going to write down the value of this log. We have log 16 to base 2. If you want to write down a value of a log, always feel free, assuming that you don't know the value of that log. Let's assume that the value of this log is x. We don't know the value, so assume the value of the whole log is x. So when you find the value of x, it becomes the value of the log. All right. So because the question says write down the value of the following. All right. So now remember from where we are coming from. If you have something like this, it is also the same thing. It implies that these two will go to take x as its own power, which is equals to what? The log number itself, which is 16. So from this particular point, you will agree with me that 2 raised to the power of x will be equals to what raised to power, 2 raised to the power of what will give you 16. Now 2 times 2 times 2 times 2 will give you 16. That means 2 raised to the power of 4 will give you 16. Now according to the law of indices, I have made video on that already. You can check the videos, they are there in my playlist. You can check the video there. Then I've made video on that. So according to indices, if these two base numbers are the same, that means the two base numbers can cancel themselves. So therefore, our x is going to be equals to 4. Then the power equal to themselves. So the value of this log is 4. Then the b part of it, we have log of 4 root 2 to base 2. What is the value of this log? Remember, we have to equate it to what? To become x, or any alphabet of your choice. And by implication, these two, we have to take this x as its own power, 2 raised to the power of this x, then everything will be equal to the log number itself, 4 root what? 4 root 2. So if this is the case, what you are going to have next is that you are going to have, at this particular point, you are going to have, look at it now, you are going to have 2 raised to the power of x to be equals to 2 raised to the power of what will give you 4 is 2 raised to the power of what? Of 2. Then times this particular root of 2 can also be written as 2 raised to the power 1 over 2. Square root means 1 over 2. So this square root can be written in this form under indices. I have treated that already. So from this particular point, you will agree with me that this is still equals to 2 raised to the power of, according to the law of indices, if you have this power and they are multiplied together by the base number, you are going to add their power. Pick one of the base number, if the base number is the same, add the power, which is going to be 2 plus 1 over 2, which is the same thing as 2 raised to the power of 2 whole number 1 over what? Over 2. 2 whole number 1 over 2. So see, 2 raised to the power s is now equals to 2 whole number 2 raised to the power 2 whole number 1 over 2. So since the base value, which is 2 here and 2 here is the same, we cancel it out. So therefore, our x now will be equals to 2 whole number 1 over what? Over 2, which is the same thing as what? 2 times 2 is 4 plus 1 is 5 over what? 5 over 2. So this becomes the value of this particular log. Alright, so now the last one, which is C, the value of log of 1 over 2 to base 2. Okay, so let's assume that the value is y. We don't know the value, so of course 2 will take y as a power to be equals to 1 over 2. Now, according to the law of indices, if you have 2 raised to the power y here, 1 over 2 is written as also 2 raised to the power minus 1. Yes, 1 over 2 is also written as what? 2 raised to the power minus 1. So that these two, we cancel these two, so therefore our y will be equals to minus 1. So, and this becomes the value of C, this log 1 over 2 to base 2. That becomes the value. Then example 3. Under example 3, we have, let's say, find the value of x in the following. Now, they give us x in each of the questions, so we are going to find the value of x. So, we have solution to example 3. The first one that we want to find the value of x, we have a here, and then that is log x to base 10 equals to what? 4. From the previous knowledge where we are coming from, you will agree with me that our log of x to base 10 equals to 4 can also be that this particular x will take it to index form now. Remember? So it will be 10 raised to the power of this 4 to be equals to what? X. So if this is equals to s is also equals to it, which means s is equals to 10 raised to the power of what? Of 4. And then 10 raised to the power of 4, 10 raised to the power of 4 is 10,000. It's going to give us 10,000. So this is why this is going to be the value of x. So now, the b part of it, we have, they said, the b part says log of x to base 2 equals to minus 6. Log of x to base, log of x to base 2 is equals to minus 6. Now, if log of x to base 2 is equals to minus 6, from the previous knowledge again, these two carry this minus 6 as its own power. 2 raised to the power minus 6 will now give us what? X, which means also, therefore, our x now will be equals to 2 raised to the power minus what? 6, which is the same thing as 2 raised to the power minus 6 here is the same thing as this minus from the indices, idea of indices. This particular minus is the same thing as 1 all over, then 2 raised to the power 6. So this is going to give us equals to 1 all over 2 raised to the power of 6 is 64. 64. So this becomes the value of x in that expression. Then number the third one now, which is C, the C part. The C part. Look at the C part here. The C part says log of 16 to base x equals to 2. If you have log of 16 to base x equals to 2, then remember from the previous knowledge x, we take these two as its own power to be equal to what? 16. Now, if you have that particular value, let me clean this please. Okay, so now remember this is, let me partition the board. Now we have x, so we are going to have, now that we have x squared, remember you are going to take the square root of both sides. Take the square root of both sides. So x squared equals to what? 16. Take the square root here, take the square root here, so that this square root will cancel this square. Therefore, you are left with x to be equals to square root of 16 is 4. So our x is now 4. Okay, now the next one is going to be the last one, which is D. The D part, you have log of x to base 81 to be equals to minus 1 over 2. If you have something like this, 81 will take this as its own power, which means you are going to have 81 raised to the power of minus 1 over 2, which is equals to what? X. So therefore, our x will be equals to, now when you have, let me still repeat it, 81 raised to the power minus 1 over what? 2. This minus means 1 over. 1 over. Then this 1 over 2 means square root, which is going to be square root of 81. Remember, you can go and watch indices. Indices, I treated this thing vividly under indices. Alright? Okay, so now we are going to have 1 over, then the square root of 81 is 9. So we have 1 over 9. That is the value of our x. So from this first part of the logarithm, this is what you are expected to learn. Now, the next thing I will be teaching us is law of what? Of logarithm. Laws of logarithm, where I'll be doing a lot of examples. So follow me fast to the next video. Alright, subscribe, don't forget to like, and don't forget to comment. Oh yeah, like now, comment now, subscribe now. It doesn't bite, it is free. Thank you very much. I remain Pastor O. Kenneth. Mathematics is made easy in Menorah Academy.